In graph 21.1, we discovered that a deadweight loss occurs on the market production when there is a negative production externality, such as pollution. This is because the market produces too much relative to what is socially optimal. There are various policies that can be used to address this market overproduction. One such policy is the imposition of a tax. In Chapter 19, we showed how to predict changes in market behavior when a per-unit tax is imposed. What we learned there doesn't change if there is an externality, because market behavior is still determined by demand and supply. Now, however, there's an efficiency reason for wanting to reduce the quantity that is produced in the market. If the socially optimal quantity is XB, we can use a tax to reduce the market quantity to the socially optimal quantity. To achieve our goal, such a tax would have to reduce the price that sellers get to PS and increase the price that buyers have to pay to PB. We know from our work in Chapter 19 that we can achieve precisely that by imposing a per unit tax T that's the difference between these two prices. Whether we impose that tax on consumers or producers doesn't matter. In both cases, a tax wedge of the vertical green amount is inserted to the left of the equilibrium and determines the new market quantity and the new prices faced by buyers and sellers. The reason XB is the efficient quantity to produce is of course because the social marginal cost curve crosses the demand curve at XB. And, as we showed in graph 21.1, the reason that the market quantity XM is inefficient is because it produces a deadweight loss triangle to the right of the intersection of social marginal cost and demand. Consumer surplus under this tax is now area A, the area above the price that buyers pay up to the demand curve. Producer surplus is the area H plus I, the area below the price that sellers get down to the supply curve. Tax revenue is tax times the quantity XB, which is equal to area B plus C plus E plus F. And the social cost that is imposed by the production of the quantity XB is the difference between the social marginal cost curve and the supply curve up to XB, or area C plus F plus I. If you add up the consumer surplus of A, the producer surplus of H plus I, and the tax revenue of B plus C plus E plus F, and then you subtract from that the social cost of pollution, C plus F plus I, you end up with an overall surplus of A plus B plus E plus H. From our work in graph 21.1, we know that the market quantity in the absence of the tax produces an overall surplus of A plus B plus E plus H minus J. Thus, by imposing the tax, we've eliminated the deadweight loss J. A per unit tax that's imposed in order to eliminate the deadweight loss from a negative externality is called a Pigouvian tax. It's an efficient tax, even though it distorts prices, because in the presence of an externality, the market is producing an inefficiently high quantity, and therefore, by distorting prices to reduce that quantity, we're able to recover the deadweight loss. In order to impose such a tax, the government would have to know what the social marginal cost is at the socially optimal quantity of output. This is sometimes difficult because it requires the government to know what the socially optimal quantity is and to be able to measure the social marginal cost at that quantity. If the government instead used the social marginal cost of pollution, the difference between the social marginal cost and the supply curve at the market equilibrium quantity xm, it would be taxing too much in our picture, because that distance is greater than the green distance at the quantity xb. Life gets considerably easier for the government if the social marginal cost of pollution is the same for each output unit, regardless of how much output is being produced. In that case, the social marginal cost curve and the supply curve would be parallel to one another, and the government could measure the difference at any quantity, including the market quantity that's actually observed. It could then estimate the social marginal cost of pollution at the market quantity and impose a Pigouvian tax equal to that social marginal cost of pollution.